Imagine looking at a city like Shanghai, New York, or London. Now look at the buildings. Thousands of them are almost completely covered in glass. For decades, those glass facades had one simple purpose: protect the inside of the building while letting natural light in. But there's something curious about them. Every single day, the sun pours an enormous amount of energy onto those surfaces, and almost all of it is simply wasted. While governments invest billions in new power plants and millions of homeowners try to lower their electricity bills by installing solar panels on their roofs, engineers began asking a completely different question. What if the building itself could generate electricity? For a long time, that idea sounded impossible. But over the last few years, China decided to invest heavily in making it a reality. And if this technology keeps evolving, the next revolution in solar energy may not happen on rooftops anymore. It could happen right in front of our eyes. When most people think about solar power, they picture the same thing: a few solar panels installed on the roof. It's such a familiar image that we naturally assume that's where electricity should always be generated. But all it takes is one look at any major city to realize there's a problem. Cities are growing upward. Skyscrapers are replacing houses. Commercial districts now occupy entire neighborhoods. Office towers consume electricity almost every hour of the day. And the taller a building becomes, the smaller its roof is compared to the total size of the structure. A 50-story building can consume hundreds of times more electricity than a typical home. Yet it still has only one roof. In practice, there's simply not enough rooftop space to install enough solar panels to power the entire building. Meanwhile, another detail goes almost unnoticed. Those same buildings have thousands of square meters of exterior facade, huge vertical surfaces, facing the sun for hours every day, covered almost entirely with glass. That's when some engineers started asking what seemed like a very simple question. What if we've been trying to generate electricity in the wrong place all along? Maybe the largest unused surface in modern cities was never the roof. Maybe it was always the facade. And it was from that simple question that one of the most ambitious ideas in modern architecture was born. There was a reason why nobody had turned windows into solar panels decades ago. The two seemed to want completely opposite things. A solar panel works best when it captures as much sunlight as possible. A window, on the other hand, exists to let that light pass through. For a long time, those two functions seemed impossible to combine. If the glass absorbed all the sunlight, it would stop being a window. If it allowed all the light to pass through, it wouldn't generate enough electricity to be useful. It was a dead end. But as new materials began to emerge, researchers realized there might be a middle ground. Instead of blocking all the sunlight, what if the glass captured only part of it? Just enough to generate electricity, while still remaining transparent. That idea led to a new generation of glass capable of integrating photovoltaic cells directly into the building's facade. In engineering, this concept became known as Building-Integrated Photovoltaics, or simply BIPV. But the idea is actually much simpler than it sounds. Instead of installing solar panels on top of a building, the building itself becomes part of the power generation system. For the first time, architecture and electricity production were no longer separate things. There was only one problem. Turning that idea into reality required massive investments, and very few countries were willing to take that risk, until one of them decided to make a very bold bet. Over the past few decades, no country has built more than China. Entire neighborhoods appeared in just a few years. Skyscrapers completely transformed the skylines of major cities. Airports, financial districts, railway stations, and commercial complexes began consuming enormous amounts of electricity. That rapid growth created an unavoidable challenge. How could the country keep expanding without relying solely on new power plants to supply every new building? It was in that environment that the concept of smart facades started gaining momentum. Instead of seeing glass as just another architectural material, Chinese companies began treating it as an opportunity. If millions of square meters of glass facades were going to be built anyway, why not make them generate electricity as well? That simple idea fueled major investments in research, manufacturing, and real-world applications of photovoltaic glass. Little by little, the technology moved beyond the laboratory. It started appearing in commercial buildings, convention centers, airports, and modern construction projects that aimed to combine energy efficiency with contemporary architecture. It wasn't a revolution yet, but it was already proving that the concept actually worked. And once multiple buildings begin producing part of their own electricity, another question naturally follows. What happens when an entire city starts doing the same thing? Imagine a modern building. Now, forget about the roof for a moment. Look only at its facade. Hundreds, sometimes thousands of windows. For decades, all of that surface had just one purpose: protect the inside of the building while allowing natural light to enter. But once those windows begin generating electricity, the entire equation changes. The building is no longer just an energy consumer. It becomes part of the energy production process itself. At first, that may sound like a small change, but multiply that idea across the scale of a large city, and its real impact becomes much easier to understand. A single skyscraper can have tens of thousands of square meters of glass facade. Now, imagine dozens of them, then hundreds. Instead of relying exclusively on the limited space available on the roof, electricity generation can spread across almost the entire exterior of the building. That's why many experts see this technology as a complement to traditional solar panels, not a replacement. Every surface starts serving a purpose. The roof continues producing electricity, but now the facade contributes as well. That means office buildings, hotels, hospitals, airports, and business centers can generate part of the electricity they consume every day. Not necessarily enough to become completely energy independent, but enough to reduce operating costs and improve overall efficiency. And there's another interesting advantage. Because the photovoltaic glass is integrated directly into the architecture, it eliminates one of the biggest limitations of conventional solar panels. Instead of installing metal structures after the building has already been completed, electricity generation becomes part of the project from the very beginning. The building is designed to produce power from the very first blueprint. It's a completely different way of thinking. For decades, architects asked, "How are we going to build this building?" Now, a new question is becoming just as important. How much electricity will this building be able to generate? And that's exactly where this technology starts to feel far more revolutionary than simply innovative. But if everything sounds so promising, why haven't we seen it become the standard in cities around the world yet? Every major innovation follows a similar path. First, it seems impossible. Then, it seems too expensive. And only years later does it become part of everyday life. Photovoltaic glass is no different. Despite the remarkable progress, this technology still faces important challenges. The first one is efficiency. Today's best conventional solar panels still convert a larger percentage of sunlight into electricity. And that's because they were designed with one purpose only: to generate as much energy as possible. A window, however, has to perform two jobs at the same time. It has to produce electricity without stopping being a window. Finding the perfect balance between transparency and energy generation remains one of the biggest engineering challenges. There's also the issue of cost. Manufacturing photovoltaic glass is still considerably more expensive than producing conventional glass. On top of that, the technology makes the most sense when it's incorporated into a building from the very beginning. Retrofitting older buildings is often far more complicated and expensive. Another important factor is that not every facade receives sunlight in the same way. The building's orientation, its height, the angle of the sun, even the shadows cast by neighboring buildings can significantly affect how much electricity those windows generate. So, this isn't a magical solution. It won't replace every solar panel, it won't solve every energy problem, And it was probably never designed to do that. Its greatest advantage is much simpler. It transforms surfaces that used to produce absolutely nothing into new sources of clean electricity. That's exactly why companies continue investing billions of dollars into this technology. They're not just looking at today's efficiency. They're imagining what cities could look like 20 or 30 years from now. And that leads us to the biggest question in this entire video. What would cities look like if almost every building also worked as a small power plant? Throughout history, cities have always reflected the technologies available in their time. When reinforced concrete became common, buildings grew taller. When elevators became reliable, skyscrapers transformed city skylines forever. Now, another transformation may already be beginning. For the first time, buildings themselves could stop being just consumers of electricity and become active participants in generating it. That probably won't happen overnight. Not every building will be covered with photovoltaic glass. Not every city will adopt this technology at the same pace, but it's worth remembering how traditional solar panels began. Just a few decades ago, they were expensive, less efficient, and often viewed as a niche technology. Today, they're part of the landscape in millions of homes and businesses around the world. Photovoltaic glass could follow a very similar path. As the technology improves, costs continue to fall, and manufacturing expands, what seems like an innovation today may eventually become just another standard feature of modern architecture. And perhaps that's the real revolution. Not replacing conventional solar panels completely, but transforming surfaces that were once passive into new sources of clean energy. After all, the cities of the future will still need glass. They'll still need building facades. They'll still need windows. The difference is that those windows may no longer exist, only to let sunlight inside. They could also generate part of the electricity that keeps those same cities running. So the next time you walk down a street surrounded by glass buildings, take a moment to look up. Because those facades, which today simply reflect sunlight, may already be showing us what the architecture of the next few decades will look like. And if this technology truly reaches a global scale, the next great revolution in solar energy may never happen on rooftops. It could happen exactly where nobody ever thought to look, on the windows themselves.